Hiya, thank you for tuning in. This is a video about circles, and the inspiration is designs like this. How did I construct it? And I want to talk about some basic constructions that we learn in GCSE that help me do this and show me why it works. That this point is a midpoint, and I know that I have a right angle here. You can see right angles better on this one. You know, how do I know that this is a rectangle? And how did I get this little star in the middle? How did I find those points? Because that's not a midpoint. And I want to talk about how you do that. So the motivation starts here. You may have done this, just dinking around with a pair of compasses. What you do is you stab somewhere on your page, swing a circle, pick any point you like on the circle's rim, doesn't matter where, start somewhere, swing another circle, and then that circle gives you 2 more points on your first circle. So you stab your compass at that point, swing a circle, stab at the next point, swing a circle, march yourself around, and you'll have 6 circles around your first circle. And then you can extend the design every time circles intersect. You just stick your compass and swing again. So I've marched the pattern out a bit here, but if I wanted to continue it, like here's a point. I don't have all 6 petals going on here, so I can stab at this point. And oh, I've done that circle. Okay, so I will stab at this point. And sometimes you forget, that's okay, it doesn't matter. And there's a circle. Okay, and then I could stab here and finish off the petals inside this circle. And off you go, around and around and around. And it can be quite meditative and soothing. I have some pro tips for compass work. Here are my 3 pro tips. First, if you've got a screw to tighten it because you want it to be really stiff. You don't want the width to get away from you. My second pro tip is to lean into the stabby end. When I draw a circle, I'm really putting my weight on the stabby point because I don't want it to skip. And my third pro tip is, I'll stab here. So I'm putting my weight into the stabby bit. And then I'm not holding the pencil upright to the paper. I lean, I tilt the compass and drag the pencil behind me like I'm sweeping a paintbrush. Just drag that pencil behind me and putting a lean, so my stabby bit is not upright. I'm leaning it over and dragging the pencil behind, keeping your weight on the stabby end, and that can help you draw reasonable circles. Another pro tip is to put cardboard under your paper. If you're going to stab your paper, you will get holes through a few sheets. I don't care, but you might. Don't do this on a nice wooden table. I've got a clipboard and paper underneath. Yeah, some basic pro tips there. So this pattern is very rewarding in and of itself. You can see it sort of look like pinched in triangles. You can perceive that pattern everywhere, or maybe you see flower petals, or maybe you see these loopy bits going around one circle, sort of like I don't know, like fancy insulation around a coffee can. I don't know. You can go to town. You might see balloon animals. I kind of start to see balloon animals when you get a line of them like this, and you got like little legs and ears and a tail. I don't know. You can start to, do all sorts of designs from here, and that's beautiful and wonderful. You can go on to do even more fancy stuff, and that's what I want to show you. Okay, so from here, I think what I want to say is, well, all right, so you grab your straight edge, and you can start doing things like, okay, connect up some points, and we'll get ourselves a hexagon, a regular hexagon. That means all the sides are the same, all the angles are the same. And that's a nice shape to know that we can construct and get that for free. You also get 120 degrees for free. That's a 120-degree angle, which I know from geometry facts. You can slap your protractor down and convince yourself that that's true. And there's a hexagon, that's nice. And we can also start drawing diagonals of the hexagon, and that's going to go right through my petals. You start to bisect your petals, and that's an interesting shape. And you might start to think about how many diagonals do you draw? Because if I start at this point, I've got 1, 2, 3, 4, 5 points I can connect to, because it's already connected to itself. I don't count that, so there's 5 other points, so there's 5 diagonals. But if I go on to the next point, I've already counted that diagonal, so there's only 4 new ones to draw, and then there'll be 3 new ones and 2 new ones and so on. And you can get into some really fun, for some value of fun, combinatorics, sorry, I'll say that again, combinatorics analysis. And you know, if that's your groove, that's great. I think counting is hard, so my attention only lasts a certain amount, but it's certainly an interesting and important question to think about combinations. I'm not doing this in a particularly methodical way here. What am I missing? This one. And you know, I haven't been super duper careful with some of these lines. The more careful you are, obviously, the nicer it will line up. That's kind of sad. I really should rub that out and do that again. Okay, so there's all your diagonals connected up, and that's quite pretty. And you've got a hexagon in the middle, and that's nice. You've got some nice kites going on here, nice kite shapes. And you know, you could draw hexagons in several circles and go to town and have fun that way. I want to show you, what's the first thing I want to show you? I want to show you why this is a rectangle. You've got rectangles here. You've got 3 rectangles going through your hexagon, and I want to show you why those are rectangles, how I know that that's a right angle. And I want to show you why this line, well, this radius and these 2 vertices connected, this is a perpendicular bisector of this radius, and I want to show you why that is. And then I want to show you how you can get midpoints on your circumference and make a dodecagon, a 12-sided polygon. Because if you have 12 points, well, 4 goes into 12. So you can make shapes based on 4, and you might perceive this as 8, you might perceive it as 4, depending what shapes you color in. If you have 12, you can do shapes based on 6 and 12. So you could argue that this is a study of the number 12, because I've got, you know, blue and white bits to my pinwheel here. And that's, I mean, endless possibilities for some value of endless. Okay, so where do I want to start? Well, how do I know that this is a rectangle? And perhaps I'll just do that in some colors. How do I know that this shape, there's so many lines, it gets really busy and hard to see, doesn't it? You should pause the video and do this along with me, because although I'm sure it's ridiculously mesmerizing to watch me do this, it's much more fun if you do it, and you will understand it better if you do it yourself. Okay, I hope that shows up decently as a rectangle. Oh, well, as a shape. How do I know it's a rectangle? Okay, well, because of symmetry, and you know, every circle had the same radius, I know that I have a regular hexagon. And I know that those 2 lengths are the same, and these 2 lengths must be the same because symmetry. And that's good enough for a parallelogram, but how do I know it's a rectangle? Well, look at the diagonals. This diagonal is a diameter of my circle, and this diagonal is another diameter of my circle. And so the diagonals are equal. And if the diagonals are equal, you've got yourself a rectangle. And that's what IKEA uses to help you put bookcases together. Because you've got the long, tall sides of your bookcase, and you got the bottom, and you got the top. Hopefully, the finishes of the wood and all in the right order, orientations. And then before you tack, the thin flimsy back onto your bookcase, before you tack it around the edges, they have you measure the diagonals to make sure that your bookcase is squared up. And so the back fits on nicely and your books don't slope. So that's a rectangle, and therefore I know I have right angles. And that's a nice thing. We are not quite at the point, there's my big circle, and there's one of the rectangles, but I really need that 12th, one of the dodecagon points to get this rectangle being perpendicular to this one. I've got 3 rectangles here, but they're not perpendicular to each other. Okay, so that's why that's a right angle. The next thing I wanted to show you was how come, and I might have to go into a new circle to do this, but I wanted to show you why this blue line is a perpendicular bisector of a radius. Why is that true? Well, it's based on how we construct perpendicular bisectors. And if you don't remember, it goes like this. And so here's a line segment of, I don't know, however long you want it to be. There are my endpoints. And the perpendicular bisector goes through the middle. It bisects it into 2 equal pieces. And it doesn't just go through at a wonky angle. It goes through at a perpendicular angle. There's a thing to say. It goes through at 90 degrees. And you construct it through the idea of isosceles triangles. Well, really, you can see it as circles or radii or isosceles triangles. So what you do is you set your compass a little bit more than halfway, and you swing an arc above and you swing an arc below. And you keep the same setting. You stab at the other end. You swing high and realize you didn't swing enough on the other point, and you swing low. So you have to go back to your first point. Just fix that. Again, you want stiffness in your compass. Okay, so what we've achieved here is from my endpoint up to the crossover, and from the other endpoint up to the crossover, it's the same length, because radius of circle. So these 2 lengths are the same. I have an isosceles triangle. Same story downstairs. And you could have, if you don't want to do upstairs, downstairs, just change the width of your compass and get a taller isosceles triangle. And the beauty of an isosceles triangle is that that altitude is perpendicular and bisects the base. I should use different marks. And I know that's an altitude because, well, how do I know that's an altitude? Maybe you can tell me. This is how you do the construction in any case. So where is this happening in our circle picture? Well, here's my line segment right here. And I swung this circle from this endpoint. And from this endpoint, I swung this circle. And I've got an above and a below, the same idea. I swung this circle from my pinky. And over here, I swung this circle. And where those arcs intersect each other, connected up, you can see the isosceles triangles right here. Here's one of them. And here's the other one. And whoop, that's going to give me a perpendicular bisector. So I know that I've split halfway. And that's useful. That can be really useful in constructions. Okay. And the third thing I wanted to show you was how to get these midpoints to construct a dodecagon. And there's a few ways you can do it. One way you can do it is to say, and this picture is a bit complicated, so I think I want to look at Where do I want to do it? Is this too busy for you? You see the center out here. This is the center of my original. If I draw that connecting line, well, heck, I can go all the way down to this one too. Here's another pro tip. If you're going through several points, line your ruler up on the end points, not on 2 points midway. So then you're less likely to go wrong at the end. Okay, so I've gone out to the next flower along and the center of my original circle, and I've drawn that line. And that's going to give me a halfway point on the arc. Again, I've got perpendicular bisectors happening with this short red bit and this entire length. And you can see an isosceles triangle here because all the radii are the same, and another one down here. And we can think about this red line as having bisected this long line. Or I guess you could see, if you want to see it this way, you can see an isosceles triangle here and one down below, and there's your perpendicular bisector. So that's quite sweet. So you can draw those lines. You'll draw 3 of them. You get 2 points for each one you draw. So 1, 2, 3, 4, 5, 6 extra points. And there's your 12 points around the circle. That's nice. Here's another way you can do it. If you don't have circles all the way around the outside, because maybe you wanted to draw a bigger circle, or you just don't want this many circles and petals, you can get this line by, how do you do it? Okay, let's look over here. Remember how I drew all the diagonals of this hexagon? I got the hexagon because of all the petals. And then I drew all the diagonals connecting all the vertices. Okay, so I'm looking here. I want to split, this side. I want to point somewhere around here. Okay, well, it turns out that this line and this line cross along that dividing line. Okay, so if you don't mind diagonals all over your picture, you can draw from the center point to where your diagonals crisscross, and that will give you one of your dodecagon points on the rim. And depending how many lines you want in your picture, you don't actually have to draw lines. If you just wanted the points, I can just smack a point on my circle, eyeballing the ruler as the line, but I don't have to draw the line if I didn't want it. Okay, so this is how you can get 12 evenly spaced points around your shape, and I think that's really nice. Here is one I did previously. I drew it big, so I didn't get my 12 points through, because my petal doesn't, I ran out of paper to draw the petal up and that dividing line. So I drew hexagon diagonals and connected. Here's 2 diagonals intersecting, and then I drew through that point up to my circle rim. And this is gorgeous. This is absolutely gorgeous. You could just, lose yourself in this picture for a while. You've got your original circle. You got the petals made, through, pick a point, swing a circle, and then from those points, swing circle, swing circle, swing circle. And you don't have to go out, you don't have to draw the whole circle. You can just sweep some arcs. You don't even have to have those lines. I had room for a circle on this side. Okay, so you got your circle with your 6 petals in it. And then you can connect those petal points up, and that's going to give you a hexagon. So maybe, pause and stare at the picture for a bit and convince yourself that you can see that hexagon. And then those diagonal crossy points gave me the extra 6 points. And I connected those up into another hexagon because I felt like it. Okay, so I've got 2 hexagons around the rim of my circle. And then I connected the 12 points up into a dodecagon because I felt like it. And I could draw all the remaining diagonals. There are some diagonals I haven't drawn, like this diagonal I haven't put in. And this diagonal I haven't put in. I mean, you can fill your page, connect all the dots. But at some point you want to start picking and choosing, I guess. And this is the basis of this. Okay, this is all the pencil marks are the same as this thing. And so I've got my hexagon in the middle. Bisected, by the way, this distance is halfway. So from here to the edge of the hexagon is the same distance as from here out to the rim, because we had perpendicular bisectors. And then, you know, I colored in every other bit to make a pinwheel. And then up here, well, if you draw that line across, it snips off the top of this triangle. And you know, I'm just coloring in alternating bits. And I'm choosing to see this triangle as an entire affair. This triangle as an entire affair and not splitting up those 2 little shapes. It just, well, I mean, I am on one side and I'm not on the other. Oh, this one, you know, you've got 2 little bits. This obtuse triangle and this right triangle. And I chose to just color it in as one thought. You know, and I'll send you a link. There's a mathematician called Becky Warren, and she does insanely beautiful shapes based on this. She starts with this as a template, and then she just goes to town with these insanely beautiful, really, really nice shapes that she finds and colors them in. So I'll put a link to that. But yeah, it all starts here. So to get to the orange shape, it's based on the rectangles, right? And now that I've got all 12 points, I can see the rectangles. Here's a rectangle. And I could draw one going across here now. And then, you know, you realize that these come out quite quickly once you've got your rectangles and hexagons and things. You can pick these shapes out quite readily. Finding these was a little bit of a challenge, and after some thought I realized that you get this square relatively easily because you've got midpoints on your rectangle, so you can get this square. But I needed to figure out this square, and I found it by realizing that one of my diagonals, you know, join all the points up of a hexagon. Yeah, join up all the diagonals of a hexagon. That diagonal whacks through one of the petals, and you just mark that point, and then you find the matching points, and that gives you the square. And then where the squares overlap each other, you know, you could have done, you know, a pinwheel like that, or like a little, I don't know, sort of looks like a Maltese cross, but you can color in the kite, and that's really pretty. So there you go. Yak, yak, yak. I hope that was clear. I hope you followed what I did. If you have any questions, give me a shout. But yeah, it all comes from, you know, playing around with the compass and connecting up the points that you get and finding some nice, and look at all the shapes you have in here. You've got trapezia or trapezoids if you're American, you know, or you've got right angles, or you've got, can you find a kite in here? If I drew from those points down to the base, I would have a kite. Or perhaps I want to keep that curvy shape. and have, you know, like a kite with concave sides. You know, there's billions you can do with this. Okay, that's where we end. Thank you for watching.